So welcome back to our third session. We're going to conclude our discussion of technology adoption and then look at the Moyker's theory. So for technology adoption, I'm going to, I was just discussing such a functional form would be appropriate, for instance, as in the Nelson-Phelps model. And then in this setup, even if we can assume that human capital is exogenous for simplicity, so it changes both across countries and across time, so there could be many follower countries, okay? In each country, human capital grows, so these are, let's say, different countries, okay? So you may imagine such stuff. So there are different countries, but then for all of them, you have to still assume something for the evolution of productivity in the frontier country. Here, the frontier country is the leader country, and we assume very simply that innovation continues in the frontier country, depending on that country's decisions on, innovation. So remember, we see a very simple model of innovative activity. Remember that model, right? So a particular fraction of the labor force, denoted by gamma star, is allocated to innovative sector or knowledge production. So you may imagine that this is country 0, and in that country, then innovation continues depending on gamma. Okay, gamma and L0, of course. Now, if that's the case, we should see something like this, right, in the data. Oh, okay, my cursor. Let me do it again. Okay, for some reason, I can't see my cursor. All right, so if that's the case, we must see something like this in the data. Suppose that this is productivity in different countries, okay? Actually, let's look at the natural logarithm of productivity, okay? When I take the natural logarithm, of course, that allows me to draw it like this for leader country. Okay, this is country 0. Now, other countries will typically start with a lower productivity. Okay, and they will realize faster than exponential growth. For instance, here it is the same, right? But then technology adoption starts, and then technology adoption ends. So that could be one country. Another country would behave like this. So there could still be some difference. Another country could exhibit this pattern. Okay. So there could be many different. So here, after this point, right? After this point, country 3 actually forges ahead. So this part is catching up. This part is forging ahead. Now, there could also be another country like here, okay? And that country can fall behind, okay? So that country could be similar to the leader. It can be leader itself, but because of crisis, because of poor management, because of institutional and cultural reasons, so on and so forth, some countries actually can fall behind the leader country in time. So as you see, that creates a lot of different possibilities, all right? Because there are, if you recall the technology we wrote, so a country's productivity growth rate depends on country-related factors, time-related factors, the human capital in the country, and the distance to the frontier. Okay. If you want to learn more, you can read my paper published in 2018 in Boğaziçi Journal. So this paper is about Turkey and South Korea. Okay. So you can also find many other papers in the literature. There's one nice paper which is called Distance to Frontier by 3 authors: Agyon, Acemoğlu, and Zilibotti. You can find this paper as well, the Distance to Frontier paper. And in that paper, the authors say that a country starts its evolution first as a follower. Okay, so this is the leader country, let's say. So the follower country first adopts technologies. So this is technology adoption. But after some point, it starts innovating. Okay, so there is an adoption phase and there is an innovation phase. Okay, and that paper, this one, discusses those dynamics. It's a technical paper. You may not understand the mathematical analysis there, but you can still read the introduction and conclusion, and you can make sense of how countries actually transit from being a technology adopter to become a technology innovator. Okay. If you have no questions, I'm going to continue, but let me pause here for a moment. I have one last task for today, which is the Moiker's theory, and I'm going to give a brief overview of it. But if you have questions now, I can answer, or if you have comments to share, we can all listen to you. All right, great. You are very productive and contributing, actually. So let me briefly talk about the Moiker's theory. So the idea is that, so this is from Joel Moiker, 2002. I think it was in chapter 1. Again, the book is called Gifts of Athena. Now, the idea is this. First, there are 2 types of knowledge. what questions and how questions. Now, what questions define what we call propositional knowledge. And how questions are prescriptive. So propositional knowledge components are things such as laws, theorems, and things like that. Okay. Now, prescriptive knowledge is like blueprints, recipes. So this type of knowledge, so prescriptive types of knowledge are giving you some instructions to build something or to do something, to create something, right? But the propositional forms of knowledge gives you the foundational knowledge about stuff, right? Now, one important conclusion is this. This has commercial value, okay? So direct commercial, oops, sorry about that. Okay, I closed it for some reason. Just a second. Okay. So what is happening here? Just a sec. So this computer got confused for some reason. Okay. Do you see it now?
Yes, we can.
All right, great. So prescriptive forms give us some direct commercial opportunities. Okay. And the important thing is this. There is a relationship between what questions and how questions. If you know, so if this is called episteme, this is techne. All right. So this is epistemological stuff. This is technological stuff. Okay. And the idea is like this. So if we know a lot about Newtonian mechanics, we can innovate certain stuff more successfully. If we know only little, we may not innovate. Okay. So in this sense, what questions are very useful for how questions? Okay. So if we know the working of air and water and pressure and friction and matter in general, then we have a higher likelihood of developing a steam engine. That's the idea. If we know how to work with paper, ink, if we know how movable type can work, then we can develop the printing machine. Okay, printing press. So that's the important classification of different forms of knowledge in Moiker. All right. But knowledge is not like knowledge has to be embodied, right? Somebody needs to know these things. So how does it work? So to understand that, Moiker offers a theory of ideas, actually. Okay, so the idea is this. So there are what Moiker calls external storage devices. External storage devices for knowledge or ideas. Okay, so you may imagine that encyclopedias Wikipedia, libraries in general, computer hard drives are such external storage devices, because basically you can store codified knowledge in such resources, right? In such storage units. So that's one thing. Now, society, of course, are made up of people. Okay? So there are many, many, many, many people in the society. Okay? They have different occupations, different levels of education, and there are many. That's important. Okay? Now, the interesting thing is this. They also have what Moiker calls internal storage devices. What is that? Internal storage devices. Well, this is brain, right? This is brain. Now, Moiker tells us this. Human beings learn stuff from external storage devices, right? They all learn, and they also learn from each other. Right? There is a network. There's a network of people, so they interact with each other. Okay? And they share knowledge. What's the third step? Well, they can store new knowledge in the external storage devices. Okay? There is actually one other component. This is just one generation, right? Let's say this is generation T. Now, what happens to the other generations? So as time passes, there is another generation here, generation T plus 1. Okay, and generation T plus 1 also have many, many members from different occupations, at different ages, different sexes, different dreams, different levels of intelligence, different levels of susceptibility to new ideas. All right? And they have, of course, their internal storage devices. Okay? And they interact with these people when they are alive It is their fathers, their mothers, their teachers, their supervisors, their bosses, their friends. But then they also interact again with each other. They're connected. And they also interact with the external storage devices. So they learn from external storage devices and they codify knowledge and they store it in external storage devices. Now the idea is this entire story, this mechanism of learning, which can be called collective learning, okay? This type of collective learning was not really operating for most of the human history. Okay, so it was there. There were storage devices. There were people. People would have ideas. People would have kids. So there were different generations. And all of these people are intelligent, at least since like 250,000 years. We still have the same cognitive capacities. Okay. But from a societal, from a social or technological point of view, that system operated only at minuscule rates. The rate of operation, the rate of knowledge generation, both in terms of propositional knowledge and in terms of prescriptive knowledge, was very small. There were wars, famines, all sorts of problems that kept life expectancy at low levels. With low life expectancy, the number of new ideas you can create was actually low. And you spend most of your time in the agricultural crop production or farming or husbandry. So in time, that progress was still there, but progress was really, really slow. So what happened? Well, what happened is this. At some point, if these are the external storage devices, and these are internal storage devices, okay, at some point, this two-way transfer, okay, was fast enough to give us what? Printing press. To give us what? Encyclopedias. And that, it gave us transportation, right? It gave us, at some point, internet and air travel. Okay? So the result of this was the enlargement of epistemic bases. There are epistemic bases. One epistemic base for, let's say, steam engine. Another epistemic base for spinning jenny. Okay? Another epistemic base for coal mining technology. Okay? Now, those were expanding. Okay? We know more about materials. We know more about chemistry. We know more about physics. We know more about all the other useful stuff, propositional knowledge. And that expansion of propositional knowledge eventually allowed us, so from episteme to techne, now we have the Industrial Revolution. And with Industrial Revolution, we even created new devices, such as microscope, such as telescope, such as thermometer, And computers. Why are these things important? Because they also affect the rate of expansion in epistemic bases. All right. So once we basically defeated that trap, once we increased the sharing of knowledge, the pace at which we share knowledge, both within a generation and across generations, we created that sufficiently large expansion of the epistemic basis for different types of innovations. Those different types of innovations eventually got realized. Some practical businessmen and some brilliant inventors were actually successful, and those successes kept accumulating. Okay? This, of course, is an evolutionary way of understanding, because it doesn't have to be fully rational agents, because maybe the network is not fully connected, right? Let's say this is a network, right? So people can be connected in this way, and there could be two agents that are not connected. Okay? So networks in real life are so complex, of course. Sometimes the knowledge created by one individual dies with it. Okay? So if you have 4 individuals, 3 of them connected, 1 not connected to any one of them. They all have storage devices, okay? And the external storage device here is there, okay? So this is the external storage device. And these people, these 3 are connected, but the brilliant idea is invented by this guy. Okay? And what happened? Well, this guy was trying to codify the useful knowledge, but at this point, he or she died. What happened? This guy was unconnected in the network, so he couldn't share his knowledge with the other 3 guys. So that wasn't happening, and he or she was unsuccessful or unlucky in codifying the useful knowledge he has or she has into the epistemic storage devices. Then the next generation, if this was generation T, then the next generation at T+1 also did not have that particular idea. So that particular idea got lost. Okay. So if you read Moiker, you're gonna see other details, a nice discussion of all these things. But let me stop here because there are other aspects that are not that central to our story. My point is, my last remark about technology is this. It is not always very simple. Don't forget that. In real life, you need to combine many different stuff for innovation or technology adoption to work. There are supply side mechanisms and there are demand side mechanisms. So for innovation to be successful, the prospective entrepreneur should be able to forecast profit opportunities. So there must be at least potentially a market for it, and that market should be sufficiently large, of course. And then there will also be the supply side determinants, such as human capital, knowledge, epistemic basis, laboratory equipment, and enough money, of course. So credit is a part of it. Macroeconomic situation is a part of it, because this is eventually a type of investment. So if you are not really certain for getting at least some profit in a proportional manner, you may be hesitating to cover the sunk costs. And the network structure matters. Our education system matters. Okay, right now in the age of high-speed internet and different types of technologies, we can of course share knowledge very easily, but that's not the only story, right? How deep is our knowledge? How central is the things that we know for technology makers? So those questions are important. And there are, of course, wild debates among technologists, economists, scientists, philosophers on various issues such as the desirability of further technological progress, the ethical boundaries that we may face because of, for instance, artificial intelligence, or because of biomedical advances, for instance. So these are highly complicated issues that have many different aspects, but here in this class, we at least try to understand the simple economic logic behind technology. And I'm going to stop here now for you to ask your questions and share your comments. Thank you. Okay. This silent moment implies what? I am the best teacher around the world. So if you have no inputs, I'm going to end the session. I'm going to upload an assignment for you and perhaps some papers that I referred to today in the class. So you may check them, you may read them. I'm going to think about your assignment topic and try to give you an exciting assignment, at least. It will be a short assignment, by the way, so don't make a big trouble out of it. And I will see you next week then on Wednesday afternoon at 1 p.m. at our original hour. Okay, at 1 p.m. we're gonna meet in our original hour. Okay, great. Thank you very much for showing up, and take care of yourselves. Bye bye.
İyi günler hocam. Teşekkürler hocam.